All right, ladies and gentlemen, welcome to your video lesson for 2.5. This is about compound inequalities today. So let's go ahead and start with a warm-up, okay? So first one, last class we just talked about solving general equalities, not compound, today's compound, right? So singular inequalities with one inequality symbol. So in this one, the first step what we would have to perform is distributing that -2 onto b plus 1, right? So -2 times b, and then -2 times 1. That gives me, oops, sorry about that, -2b plus -2 plus 4, that just goes along for the ride, is less than 10. I notice that I have like terms here, right? -2 and 4. That's going to give me, this is going to be annoying. That gives me, let me just do this. That, boom, 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 boom. All right. Sorry about that. All right, so that gives me the -2b plus 2, and that is less than 10. So now I have a two-step inequality. What's happening to b? It's being multiplied by -2. I add 2, so my first step is subtract 2. Undo that. That gives me with 8. Then I have -2b is less than 8. Now here is something that is tricky. Remember, I'm dividing by a negative. It's not just because I'm dividing, right? It's because I'm dividing by a negative. If I divide by a negative, I have to flip the sign. So then I'm left with b is greater than, and then 8 divided by -2 is -4. All right? Graphing that, I have an open circle because there's no line underneath, and my arrow goes to the right because it is greater than. All right, next one. So I have -6 is greater than 5n plus 4 plus 5 plus 4. Well, I have like terms to start off with, right? So I'm going to go ahead and combine those. That leaves me with -6 is greater than 5n plus 9. I have a two-step inequality, so now I have to solve it. So I'm going to subtract 9 from both sides. That's going to give me -15 is greater than 5n. Divide both sides by 5. I do not flip the symbol because 5 is not negative. That leaves me with n is less than -3. And that's kind of important to note, right? I'm reading that from the variable perspective, which you should always do. Always read from the variable's perspective because the same statement is n is less than -3, like that. All right, so graphing that, I have, just less than -3 here, open circle, and arrow going to the left. All right, digging into today's stuff, compound inequalities is what we're talking about. So today we're taking, basically we're putting two inequalities into one statement. All right, so we're going to start off with a little bit of an exercise in truth tables. All right, so definition you guys got to get. Compound statement. What is a compound statement? Compound statement is formed by combining two or more simple statements. Remember, at any moment you can pause this video to catch up and write this stuff down. A compound statement can be true or false. And these are the two main words we're going to be dealing with here. The word and or. So an and statement, a statement involving and is true when both statements are true. So like think of it this way, right? If I have a game and I say I win the game if I win round 1 and I win round 2. Well, that means I have to win both rounds in order to win the game, right? But if I say instead or is true when only one of them is true, well, then if I say I win the game if I win round 1 or round 2, well, now I only have to win one of those rounds and I'm a winner, right? So that is the introduction to the difference between those two. That's going to be a focus later on. All right, truth table stuff. All right, so we are given statements here, P and Q, and then we're comparing those statements with the word and. All right, so the first statement is dog is a mammal. Well, that is obviously true, right? I have to write these in. That's true. Red is a color, obviously true. And now what I'm saying, I have both of them combined with the word and. I have a true statement combined with a true statement. They're both true, which means the overall statement is true, right? So first one, a dog is a mammal. Yep, still true. Red is not a color. Well, that's false, right? Now I'm comparing a true statement with the word and with a false statement. Well, because one of them's false, they're both false. The whole thing's false. Okay? Dog is a fish. Nope, that's false. Red is a color. Yeah, that's true. So now I'm comparing a false statement with the word and with a true statement. And because one of them's false, the whole thing's false. All right, last one. Dog is a fish. Nope, false. Red is not a color. Nope, false. And the whole thing's false. Doesn't matter if it's and or, right? Both false. Okay, so now let's, like, P and Q is true only when all statements are true. That says are true, okay? Only when all statements are true, okay? So if I'm using and I have two statements, both have to be true in order for the whole thing to be true. All right, next one. So now we're using the word or, okay? So 1 is an odd number. Yep. 2 is an even number. Yep. Now I'm comparing a true statement and a true statement with the word or, and because they're both true, and I only need one of them to be true, the overall statement is true if I combine them, right? So saying that 1 is odd or 2 is even, that's true. All right, individual statements. 1 is an odd number. True. 2 is an odd number. Nope. False. So now I'm comparing a true statement with a false statement using the word or. And because one of them is true, the whole thing is true. Same thing's going to happen here. 1's an even number. That's false. 2 is an even number. That's true. And so for the same reason up here, we can say that this is still true. And then both of these are false. 1 is an even number. Nope. False. 2 is an odd number. That's false. And so because both of these are false, it doesn't matter if it's and or, it's false. So P and Q is true when one statement is true. Okay. All right, moving on here. So we're going to first take a look at the and inequality. All right. So and involves intersection. What I would like to say, it involves overlapping region. Okay. Involves overlap. So take a look. I'm graphing x is greater than 2, which individually would look like this. But I'm also graphing x is less than 6, which looks like that. Okay. And if I'm joining them for a compound inequality using the word and, that means I need things to be true for both inequalities, right? They have to be both greater than 2, but at the same time less than 6. Let's say that again. They have to be greater than 2, but at the same time less than 6. Where does that happen? Well, that happens in between 2 and 6, right? So that's why the final graph looks like it does. It's an open circle on 2. Shades in everything that's included between 2 and 6. Open circle on 6. Okay. Another and graph, right? So again, this involves overlap, right? If I graph both of these individually, they kind of look like that, right? Where does the overlap exist? Right in between. Okay. Same thing. This is greater than or equal to. Well, that's the only difference here is that we have a filled in circle. All right. And so individually, that graph looks like that. And x is less than or equal to 6. Again, filled in circle. Individually, that looks like this. Okay. Because it's an and graph, we're looking for overlap. And where does the overlap exist? It exists right in between. So that's why our final graph looks that way. Okay, so again, overlapping graphs will always be and. Graphs that go together will always be and graphs. Okay, so next thing you need to know is how to determine if it's an and graph. So here's what the first tip, okay? Anything that compares, look at these here, anything that compares x or any other statement, right, to two numbers at the same time is an and graph. I'm saying x is less than 2 and x is greater than 1. So if you ever see an inequality, a compound inequality that has two inequalities in it, it's always and. All right, so we know that right off the bat. So here's what we got to do. I'm actually going to erase some stuff here. I'm going to give you a visualization. All right, so I'm going to take a box, fill it in. And I'm going to get rid of something, okay? Here's what we got. I got this x plus 2. It's in the box, right? And I'm saying that has to be less than or equal to 8 and greater than or equal to 4 at the same time. There are two statements there. The first statement is the x plus 2 is less than or equal to 8, okay? My first step in solving these compound inequalities is split, right? I have to split inequalities, okay? So one of the inequalities is that x plus 2 is less than or equal to 8, okay? And then the other inequality is that same x plus 2, but it is greater than or equal to 4. So I have 4 is less than or equal to x plus 2, right? And so now I've split. Look, it's that same x plus 2, but then split. So when you have an and inequality, the first thing to do is split, and then you solve them individually. So now I'm going to just solve it. Each of the steps are pretty simple here, right? What's happening to x? I'm adding 2, so I'm going to subtract 2 from both sides. So I got 2 is less than or equal to x. Over here, it's the same exact step, right? Subtract 2 minus 2. I get x is less than or equal to 6. Okay, so now I have basically the same inequality that I had up above, okay? And I have to now join these with the word and. And I knew it was and because I recognized how the inequality was formed from before, okay? So this is my final answer. What are the numbers that satisfy this inequality? Well, they are values of x that are less than or equal to 6, but at the same time greater than or equal to 2. So I graph that. Well, when I draw the graph, I literally only want two numbers on the graph. I want the big number on the right. I want the small number on the left, because that's how number lines work, okay? And then I graph each one individually. All right, x is less than or equal to 6. Fill in circle, arrow going to the right. X is greater than or equal to 2, and filled in circle, arrow going to the right. Okay, I think I said right for this one. Arrow's going to the left. Okay. So then I ask myself, where does the overlap occur? Well, the overlap occurs right in between 2 and 6. So that is my final answer. Okay. The other way to do this is to just say, all right, there's 2 here, there's 6 there. And then sometimes people like to graph above the number line. That works just as well. They both mean the same thing. All right. So one more example here showing, I look at this compound inequality. I'm looking at this. I'm like, cool, I got two inequality symbols. I'm taking that 3x plus 2 and I'm comparing it to 8 and negative 10 at the same time. So I know that this is an and inequality. First thing I'm going to do is split, right? That's my first step. So negative 10 is less than 3x plus 2. And the other one is that same 3x plus 2 is less than or equal to 8. So the steps are the same for both. Subtract 2, subtract 2. I get negative 12 is less than 3x. Same thing, subtract 2, subtract 2. 3x is now less than or equal to 6. Divide by 3 on both sides. I do not flip the sign because it's not negative. I get negative 4 is less than x. And divide by 3 over here. Again, it's not negative, so I get x is less than or equal to 2. Those are my two inequalities. I now have to put them together with the word and what I'm going to do is, no, I can't do that. Here's what I'm going to do. I'm just going to write negative 4 is greater than x, and now put the and word in between. So this is my final answer, okay? Then how do I graph that? Individually, right? Small number on the left, big number on the right. 2 is here. That's going to be a closed circle, arrow going wrong way. Less than, right? And open circle on negative 4 and my arrow going to the right because it says x is greater than 4. And my final answer is shaded in between. Okay, so and graphs. First thing to do, split it into two individual inequalities, right? Solve each individual, put your answer back together like I have right here, and then graph them individually, and then ask yourself, where does the overlap occur? And it's always going to occur in between, right? You're never going to have stuff out here for your and inequalities. All right, now talking about or. So or does not eliminate any solutions, right? Or keeps everything. And we don't look for overlap. If you look at this, I have x is less than 2, which is this graph right here, or x is greater than 6, which is this graph right here. Okay, and what you'll notice right away is that OR graphs always go in opposite directions. They don't overlap, they go in opposite directions. So that's one thing that we got to keep in mind. And the only difference between these two graphs is that we have filled in or non-filled in circles according to the symbol, right? These are not filled in. But if you look at them individually, it's not very difficult to sort out. It's like, all right, well, x is less than or equal to 2. Well, I can graph that, no problem. And x is greater than or equal to 6. Well, I can graph that, no problem. It's just that there's no thinking about what has to be eliminated, right? There's no overlap. There's nothing to think about there. So you literally, when you're done solving an OR inequality, you just graph it and you're pretty much done. All right, so let's solve a practice compound inequality using the word OR. Here's the thing. You will always know if it's an OR inequality because it will always say OR. ORs always say that, okay? So what we have to do is just literally solve each one. There's no splitting involved. So OR inequalities are a little bit easier because there's no thinking about how to set it up. We just can go straight ahead and solve it, right? If I look at this, if I look at this one, okay, well, what do I got to do? Well, I got to add 4 to both sides. Plus 4, plus 4. That gives me x is greater than 5. And I still have that same negative 4 plus x. I'm going to add 4 plus 4. And I get x is less than 1. What's my connecting word? OR. Done. This is my final answer. So now I just go and I graph these on my number line. Again, small number on the left, big number on the right. I graph them individually. First one is x is less than 1. That is an open circle and my arrow going to the left. Next one is x is greater than 5. Open circle, arrow going to the right. Done. That's all I need to do. So again, OR graphs, there's no splitting. We just straight up solve each one and then put them both on the same graph. Another practice one, okay? So again, it's OR because it says OR. So I'm gonna go straight up and solve this. So plus 1 on both sides. I get 4x is less than 16. Then last step is divide by 4. Divide by 4. I get x is less than 4. So that's that half. This one is just one step. I got to divide by 8. I get x is greater than or equal to 6. Now my final answer, I know, has to have the word OR in it. So I have x is greater than or equal to 6. And this one is x is less than 4. And I've connected it with the word OR. So that is my final written out answer. Now, if I want to graph this, again, I graph individually. Small number on the left, big number on the right. This one is x is greater than or equal to 6. That is a closed circle, arrow to the right, arrow. This one is x is less than 4. That is an open circle, arrow going to the right. So, OR compound inequalities are a little bit easier. And compound inequalities, you got to think a little bit. You got to think about the split for and. But after you split it, there's really not that much difference until you go to graph, and then you have to think about the overlap. With an OR graph, there is no overlap, so it's a little bit more straightforward. All right, so kind of a reflection question. What must be true in order for an answer to a compound inequality involving OR be the set of all real numbers? Well, I kind of gave an example here, okay? What if I said that x is greater than 5, greater than or equal to 5, or x is less than or equal to 5? Well, if you graph those each individually, you'd start with a filled in circle on 5, and one would have the arrow going to the left and one would have the arrow going to the right. This would indicate that all numbers are solutions, which means this would be the set of all real numbers. You'd have to have an inequality where you have x is greater than or equal to some number, and then x is less than or equal to some number, and have that number be the same, like 6, okay? Then you would have the set of all real numbers. What kind of compound inequality has no solution? That's going to be an inequality, an and inequality, and would have no overlap. An and inequality with no overlap would be no solution, because overlap is what is required for a graph, right? Basically, if I took, let's take this one here, and I was like, okay, this is my final solution for an and inequality. If that was the case, well, then this would be no solution because there's no overlap, okay? So and requires overlap. If there isn't any, then we have no answer. All right. Last thing we're going to talk about here is about how to go, so we started with a compound inequality that we solved, and then we graphed it, right? And now we're going to work backwards. I'm going to give you a graph, and you have to come up with the compound inequality that goes with it. This isn't too bad. First thing you got to do is decide if it's an and or an or graph. So if we look at the first one, I think it's pretty clear because the graphs go in opposite directions. We talked how that has got to be an or, okay? The first thing you're going to do is write down the connecting word, right? The connecting word here is or. Then you have to figure out, well, what am I connecting? What are my two inequalities? And literally just go look and say, all right, well, what does this one say? Well, this is graphing values that are equal to 7, but also bigger than 7 or greater than 7. So that's going to be x is greater than or equal to 7. And then look at the next one. What is this one going to be? Well, this is graphing values that are equal to -1 or less than that, right? So that's going to be x is less than -1 and less than or equal to, sorry. And that's all you got to do. First decide if it's and or, and then individually write out what the two inequalities are. So the next one, if I look at it, this is connection, right? So the original graphs, remember, would look like this. They'd have some overlap. So they go this way and they go that way. And then we'd say, well, where's the overlap? It'd be right in between here, right? And then we're left with this resulting graph. So what you have to do is put your connecting word in, and just like we did before. And then what am I connecting? What is one of these graphs, right? So the one on the right is x is less than, this one is less than -3. So x is less than -3. What is the other one I'm connecting? This is saying that x is greater than -8. And I'm done. That's all I got to do. Again, all I'm doing is deciding, is it going to be and or? I'm writing down that word first, and then I'm just literally mapping out, all right, well, what are the two inequalities, and then writing them down. It's not too terrible. All right, describe a graph that must be represented by a compound inequality that's involving and. That graph is going to be any graph that is connected together, right? Or shaded in the middle, could have a filled in circle or not, but it's going to be connected, okay? And what do the words inclusive and exclusive means? Inclusive means that it includes the end parts. Exclusive means that it doesn't include the end parts. We don't really use that too much in our class, but sometimes people use that. So exclusive means to exclude, or excluding the endpoints. Inclusive means to include the endpoints, and that's referencing to and graph. All right, last example here, and then we're going to be done. All right, so I can express the quality control levels in a real-world problem using compound inequalities. The pH level for a swimming pool water is in between 7.2 and 7.6 inclusive, right? That means it's including endpoints. Including endpoints. So let P be the pH level of the swimming pool. All right, well, here's P, okay? And it has to be inclusive of these 2 points. So what is the highest one? Highest one is 7.6. What is the lowest one? 7.2. So that value has to be between here. So it has to be less than or equal to, because it's including 7.6. But it also has to be greater than, so from the variable's perspective, this says P is greater than 7.2. And that would be my final answer for that, okay? So, excuse me, you could also write it like this. So P is less than or equal to 7.6, and B is greater than or equal to 7.2. That would also be a correct answer. All right, ladies and gentlemen, hopefully this helps supplement your understanding. Make sure you do your independent practice, 3 through 17 odd and 20 through 25. I hope you guys are all having a great day. See you later.